Stanford scientists discover a crystal that thrives in extreme cold, a game changer for quantum tech. Scientists at Stanford University have uncovered something extraordinary, a simple, inexpensive crystal called strontium titanate, STO, that improves when it gets colder, especially near absolute zero, the coldest temperature possible in the universe. If you like my content and want to listen more interesting science stories like this, then subscribe my channel. And don't forget to like and share this video with your friends and colleagues. Most materials become brittle, weak, or stop working altogether in extreme cold. But STO does the opposite. It gets stronger and more responsive, showing remarkable optical and mechanical properties that make it perfect for quantum computers, lasers, and even space exploration. A crystal that defies the cold. In a new study published in Science, Stanford engineers found that when STO is cooled to cryogenic temperatures, it not only keeps working, it performs far better than any other material tested under similar conditions. Quote, "Strontium titanate has electro-optic effects 40 times stronger than the materials we use today," said Professor Jelena Vukovic, who led the research. It also works beautifully at extremely low temperatures, which is crucial for building quantum devices. End quote. That's big news, because quantum computers and superconducting systems, technologies behind the 2025 Nobel Prize in Physics, only work at ultra-cold temperatures. Finding materials that can survive and even thrive under those conditions has been one of the biggest challenges in physics and engineering. Why strontium titanate is so special? STO has two key superpowers: nonlinear optical response. When an electric field is applied, STO changes how it bends, reflects, and transmits light, almost like a dimmer switch that can reshape light on demand. This lets scientists control light in ways no ordinary material can. And piezoelectricity. STO physically expands or contracts when exposed to electricity. This makes it incredibly useful for devices that convert electrical energy into motion or sound, especially in the freezing vacuum of space or in cryogenic fuel systems used in rockets. At low temperatures, STO becomes the most tunable optical and piezoelectric material ever tested, meaning its behavior can be finely adjusted with great precision. An old material with a new purpose. Interestingly, strontium titanate isn't a new discovery. It's been known for decades, and even used as a cheap diamond substitute in jewelry. It's abundant, affordable, and easy to produce. Quote, "STO isn't rare or exotic," said Dr. Giovanni Scurri, one of the study's authors. "But we realized that under the right conditions, extreme cold, it behaves like a completely different, extraordinary material." End quote. The Stanford team didn't stumble upon STO by chance. They knew what properties were needed for highly tunable materials and found that STO already contained the right ingredients. They just had to look at it from a new angle. Breaking records at near absolute zero. When the team cooled STO down to just 5 Kelvin, about minus 450 degrees Fahrenheit, they were amazed. Its ability to manipulate light was 20 times stronger than lithium niobate, the top material used in modern optical devices, and 3 times better than barium titanate, the previous record holder for cold performance. To push things even further, the researchers swapped some of the oxygen atoms in the crystal with heavier isotopes. This subtle tweak boosted its tunability by another 4-fold, moving it closer to a state known as quantum criticality, where materials exhibit extreme responsiveness. Quote, "We tuned the recipe perfectly," said Dr. Christopher Anderson, co-lead author. "The result was the most tunable material ever seen for these conditions." End quote. Shaping the future of quantum and space technologies. Beyond its amazing physical properties, STO is also practical. It can be grown, shaped, and patterned using standard semiconductor tools, the same ones used to make computer chips. That makes it ideal for future quantum switches, light-based circuits, and laser components that operate in deep cold. The research was supported by Samsung Electronics, Google Quantum AI, and U.S. government programs like the Department of Energy's QNext and the Department of Defense's Vannevar Bush Fellowship, all eager to find new materials for next-generation quantum devices. Quote, "We found this crystal sitting on the shelf. It turned out to be amazing, and once we understood why, we made it even better. Now it's possibly the best material in the world for cryogenic optical and mechanical technologies." End quote. The big picture. This discovery shows that groundbreaking materials don't always come from exotic sources. Sometimes they're ordinary substances hiding extraordinary potential, waiting for someone to look at them under the right conditions. Strontium titanate could soon help power quantum computers, space missions, and advanced laser systems, all by doing what no other crystal can, becoming stronger as